Hello, ladies and gentlemen, and welcome back. This is Prospect Charter School's Algebra 1 class. We are now in section 2.1, and I am stoked. I have just finished grading the tests for this year, and they are awesome. I have never had a class do as well on their first test in Algebra 1 as this one. So, good job. Kudos to you guys, and let's get started with our next section. Our next section is solving by adding and subtracting. So solving equations, let's make sure we can read that cue there. Equations by adding and subtracting. This is the first part of the four-step equation system, which is adding and subtracting. So the first thing we have to know is, what is an equation? After all, if we don't know our definitions, that's right, we don't know what we're talking about. And if we don't know what we're talking about, we kind of look silly. So let's not look silly. Let's look at what an equation is. An equation is different than an expression. An equation is two algebraic expressions being compared over an equal sign. So what does that mean? Well, one, it's going to need an equal sign. So if it doesn't say something is equal to something else, then it is not an equation, it's just an expression. So an equation is a little bit different. It's two algebraic expressions being compared over an equal sign. So a question for you, is this an equation? The answer to that question is no, Mr. Neal, there's no equal sign, so it can't be an equation. All right, so that one gets the big red X. Then let's try another example. Is this one an algebraic or an equation? Well, if you were smart, you would say, yes, it is. And I think you're going to be going, but Mr. O'Neill, this isn't an algebraic expression. It doesn't have any variables in it. Well, that's true, but an algebraic expression doesn't necessarily need to have the variables included. This one could say that we have plus 0 x's. And what's 0 times x? Yeah, it's 0. Do we bother writing down plus 0? No, we don't. So when we see a whole number by itself, or actually any number, any real number by itself, it can be considered an algebraic expression, even if it doesn't have variables, because we can always add the plus 0x to it. So when we're looking at these guys, we're going to be looking at solving equations, which are two algebraic expressions being compared over an equal sign. And what happens when you solve it? To solve means to isolate the variable. I'm going to say indicated variable because there could be more than one. To isolate the indicated variable on one side and everything else on the other. I have to scroll down a little bit here. So what does that look like? Well, it looks like we have our indicated variable on one side and then everything else on the other side. So if we're looking at this, we would have said we solved for x because everything else is on the other side of the equal sign. What about if I saw something like x minus 4 is equal to 8? Is that solved? The answer to that question is no, because we have that negative 4 hanging out with our x, so that's not solved yet. What about something like 4x is equal to 21? Again, no, the 4 is hanging out with our x, so it is not solved. Okay, what if we saw something like x squared is equal to 16? Well, again, no, because we've got the 2 hanging out with the x. For it to be solved, the indicated variable must be all by itself. No powers, no exponents, no you can have subscripts, but no coefficients, nothing else, nothing being added or subtracted, nothing. It needs to be absolutely by itself, and only invisible ones may hang out with it. That's what it means to be solved. So this one is not solved, this one is not solved, this one is not solved. The only one that's solved is the one that's on top, which is why it's called a QT pie. All right. Let's go on to our next point. How do we solve? Well, to go with how do we solve, we have to have a rule about solving and a rule about equations in general. That rule is really simple. The rule of algebra. And it is what makes algebra the most powerful tool in mathematics. The rule of algebra is as follows. What you do to one side of an equation you must do to the other side as well. For example, let's look at the algebraic expression, algebraic equation. Haha, I caught myself there. 5 is equal to 5. Now, do we agree that 5 is equal to 5? I really hope so, because everything is equal to itself, always. That's the reflexive property of all numbers in the universe. So if 5 is equal to 5, what would happen if I subtracted 3 from one side? Well, if I only do it from one side, suddenly I have 2 is equal to 5. Now, is this true? Answer to that question is no. No, it isn't. It's most definitely not true. 2 does not equal 5, unless you're talking about relationships in many years down the line. But 2 normally does not equal 5. So we can't do it that way. So if we subtract 3 on the left-hand side, what happens if we subtract 3 on the right-hand side? Well, when we do that, we get 2 is equal to 2. This is a good thing. 2 is indeed equal to 2. It's part of the reflexive property. So when we're looking at them, as long as we do something to one side, if we do the exact same thing to the other side, they remain equal. Don't believe me? Well, let's try multiplication. Let's say that we have 4 is equal to 4. And then I multiply both sides by 1/2. And I know some of you thinking, but Mr. Neal, that's really dividing by 2. Yeah, same difference. So when I multiply both sides by 1/2, I end up with 2 is equal to 2 again. Now what happens if I add 7 to both sides? Well, then I get 9 is equal to 9. Now what if I broke one of those 9s up into 5 plus 4? And then I wanted to subtract 4 from both sides. Then what would happen? Well, 9 minus 4 would give us 5. And then over here on the right-hand side, we have 5 plus 4. And then minus 4, the positive 4 and the negative 4 cancel, and we end up getting 0. And 5 plus 0 is 5. So as long as we do the same thing to both sides of our equation, they will always remain equal to each other. So the main rule of algebra, and this will follow through from now until you get through the highest levels of calculus that you can possibly get to. And the rule of algebra says what you do to one side of an equation, you must do to the other. Otherwise, they're no longer equal. Okay, so let's go on to the next part. And the next part is, well, let's get some examples in. Examples time. Yay! All right, I can tell you guys are excited. I'm excited. You might not be, but I'm excited. All right, so let's do some examples. For an example, let's say that we are told to solve for x, and we are given that x minus 10 is equal to 4. How are we supposed to isolate the x, right? That's what it's telling me to do. Solve for x means I need to get x by itself. So to do that, I need to get rid of whatever is hanging around with the x. So do I have a number that's multiplying x? Well, no, there's just 1 there, and that's okay. 1's pretty much invisible anyway. What about exponents? Well, again, there's a 1 there, so we don't really worry about it. What about adding and subtracting to it? We've got that negative 10 being a little bit of a hang-around person with our x, and we don't like that. So what do? We have to get rid of that 10. So how do we get rid of that 10? Well, I would like to just add 10, because negative 10 plus 10 goes to 0. But what I do to one side, I must do to the other. So I'm going to have to add 10 on the other side of the equal sign. And a cool trick that you can do is put a little dotted line here as like a border on the equal sign. And what you do to one side of the border, you have to do to the other side, just to keep things balanced. So looking at this, we would have x minus 10 plus 10, which becomes just plain old x, because x plus 0 is x. And on the other side, we have 10 plus 4, which is 14. And we end up with x is equal to 14. Now, is the x completely isolated? Well, it doesn't have anything hanging out in front of it. It doesn't have anything in its exponent. It doesn't have anything being added or subtracted to it. It's all alone. It is completely by itself. And everything else is on the other side of the equal sign. So this is what it means to be solved for. We have solved for x. X is equal to 14. Now, how do you check your solution? To check, you plug in your answer. I'm going to say suspected answer. And see if it works. If it doesn't work, then you obviously have the wrong answer, or it could be a very special case, which we will get into later on, especially when we're dealing with things like absolute values. Water, how I love you. Can't live without you. All right, so here we go. We were originally given x minus 10 is equal to 4. We discovered that our x should be equal to 14. So I plug in 14 for x and see what happens. Now I have 14 minus 10 is equal to 4. Now, is this a true statement? Is 14 minus 10 equal to 4? Well, yes, it is, because 14 minus 10 is 4, and 4 is indeed equal to 4, so it checks out. This is indeed the correct answer. We have checked it, and it works. So, let's do a quick review. To solve for x means that we get x by itself and everything else on the other side of the equal sign. So, we did that to begin with when we were given x minus 10 is equal to 4. We added 10 to both sides to eliminate the 10. So my justification side, I would say, add 10 to both sides to eliminate the 10. And then what do you know? Bam, we've got our answer. We have x isolated by itself on one side and 14 on the other side. we can, of course, say Shazam. And then the next portion, it says check, plug in the suspected answer and see if it works. So we plug in 14 because we think that's a suspected answer, and evaluate. Now, you guys should remember what evaluate means. It means plug and chug. We plugged in 14 and then we evaluated. We reduced it down to its simplest format, and its simplest format was 4 is equal to 4. And at the end here I can say, since both sides are equal, (14) is a solution to the equation. If I got something like 6 is equal to 4, it's not an acceptable solution because it gives you an erroneous answer, meaning it's full of errors. So we want to make sure that they are the same. If they're different, they get kicked out. If they are the same, we get to keep them, which means that math must be extremely racist. Oh well. That's actually a joke. Math isn't racist. It is completely colorblind. It doesn't care about anybody. It just is. Kind of like the sun or the moon. I don't think those are racist either. All right, so let's go ahead and look at another situation where we would have a few difficulties. Let's look at example number 2, which will be 2/5 is equal to m minus 1/5, and we are told to solve for m. Now, I know what you're thinking. Oh my god, fractions. And you're like, no, because it's fractions. Well, guys, just remember, fractions are friends. They really are friends. Especially fractions with the same denominator. That's right. Both of these fractions have the same denominator, which will make adding, subtracting, multiplying, and dividing them so much easier. So let's start out by asking ourselves, okay, what are we asked to find? Well, we're asked to find m. All right, well, what's hanging out with m? Well, this minus 1/5 is hanging out with m. How do I get rid of that minus 1/5? Well, I would just add 1/5 to both sides. And then see what I get. 2/5 plus 1/5, because the denominators are identical, I don't have to worry about changing them. I just add the numerators. So 2 plus 1 is 3, so I have 3/5 on the left. And then on the right, the minus 1/5 and the positive 1/5 cancel each other out, and we're given 0, which means that we're left with just m. So 3/5 is equal to m. Now, have we solved? Well, in the previous example, I'm going to use pink for the previous example, we said that x was equal to 14. Note that the x was on the left. This time the thing I'm solving for is on the right. Is that going to make a difference? And the answer to that question is no. It makes no difference. You can have your variable isolated on the right-hand side of the equal sign, or you can have it isolated on the left-hand equal sign. It doesn't matter. It's both left and right-handed. In fact, equal signs are very ambidextrous. So since we have our variable on one side and everything else on the other, have we solved for m? By now you should be shaking your head and saying, yes, Mr. O'Neill. Yes, we have solved for m, because we have. All right. And of course, I'm going to erase this, and we're going to look at our justifications, and we're going to do our justifications in purple, because that's what red plus blue is, purple. And we say for our first line, add 1/5 to both sides to isolate m. All right. Well, you've been a wonderful audience. I thank you so very much for your time. I'm going to leave the rest to you guys. And I think I'm going to give you some exercise and practice to work with, because with math, it's really like a lot like a sport. If you don't practice, you ain't going to get better. And I know we've said that like 100 times in like the 100 videos that we've made so far, but it's true. It will always be true. Practice, practice, practice makes such a huge difference. If you don't practice, you won't do so well. In fact, on the test that I gave you, you know how I was like super excited. Oh my God, they did so good. Well, they did good, and they did very good, and the ones that did the practice and showed their work did way better than those that I would go up to in class and say, I need you to show me your work. And then they said, oh, I can just do it in my head. Kiddo, you got to do it. You got to show your work. You got to do it on paper. You got to practice. Because this was the easiest test that I'm going to give in Algebra 1. They're only going to get harder from here. And if you don't get your practice in, you're going to fail. And it's okay to get things wrong. It's okay to experiment, and it's okay to learn. But when it comes to game day, if you fail at catching that ball when it's flying towards you in center field, and suddenly they get 4 runs off of it and they win 4-2, you failed. And it does hurt. It does make a difference, because that one win might be the difference between making it to the playoffs and not. Might be the difference between winning the World Series and not. So it's okay during practice to fail 100 times. But come game day, you gotta have it down. And that's why it's okay to fail at practice, but it's also okay to practice. I need to see you practice. I need to see your work. So let's look at it. This is going to be section 2.1, which is on page, let me see, what page is this? This is page, it should be page 80 in your textbook, but I'm not really sure. Knowing what section it is, you can always look up which section it is, and it varies from page to page, number to number. But if you look at the section, you'll always know where you're supposed to be. Now let's look at numbers. 357, 1113, 1719, 21, 23, 25, 29, 31, 35, 39, 41, 44, 45, 47, 49, and then some good practice that we need to work on. We need to do 51, 55, and because word problems are awesome, 59. Now I know that's a lot of problems, but what have I said before? If you've got a lot of them, they're probably going to be easy. All right, that's all. Good luck and have fun.